Hello friends, welcome back to my YouTube channel Infinite Knowledge, and I am back with some unique series of electronics circuitry, and this is a second video of my electronic circuitry series. So in the previous video, what we have understood, what we have learned how to make a simple inverter using Arduino Uno. So what was the purpose of Arduino? Arduino give the switching supplies to this MOSFET to switch on and off for a particular time, and you are getting a very clear output waveform. You can see here. Okay, this error occurred due to I had not add the program. So if you want to see this video, the link is given in the description box. And we are back with some unique series or with some unique concept, and this is the second video of this electronic series. So let's get started without wasting any milliseconds. So I have considered the universal IC, IC-555. IC-555 is the most lovable IC for electronics engineering, and each and every circuit you can get this IC for a minor circuit to a major or very complex circuit. So it is a very useful IC. You can do anything what you want by this IC-555. So here I am just giving us some brief of the IC-555. So you know about the IC-555, I think so. So here IC-555 has a three different modes, and we are using a astable multivibrator mode. We are using a IC-555 in the astable multivibrator. So what is the astable multivibrating mode? Astable multivibrating mode means the output pin. Output pin is a 3 number. You can see here the 3 number pin is the output pin. Output pin change its polarity or its voltage level at a particular time. So you can see for a particular time it is a 0, then particular time it is a 1, and then again particular time it is a 0. There is no any external signal to change its state, but there are three modes. There are three modes in the IC-555. One is a stable mode, one another is a monostable mode, and last one is a bistable mode. So what is a monostable mode? Monostable mode means it will remain in one state. Once it gets a trigger, it will change its output state for a particular time. Here you can see for a very less time, very particular time, very precise time, it's remain high state and again go back to 0. There is no any signal required to go back to 0. It will automatically go back to 0 by some values, some capacitors and resistance value. According to that, this state will define. Here again in bistable mode, what you require? You require a signal. Once the signal is occur, it will change its state from 0 to 1, and it will remain in the 1. And once again external input is occurred or external signal is occurred, it will change its state. So if at this moment if this signal is not occur, it will remain continue. So here we are using astable mode because these two are not applicable for our purpose. Because what you need to do, you need to switching on and off this MOSFET for a particular seconds, for a particular time. So that's defined by their resistance that is used and the capacitor that is used here. So R2, R1 and C3, these three are major components to get output, to get a proper output for a proper time. So what is I think so you are aware about the IC. So just I am giving you the what is the output, how output look like. So this is IC-555, and you know the pin diagram 1 2 3 4 5 6 7 8 like this. But the 3 number pin is our output pin, and the output of this IC-555 is like 0 1 0 1 0 1. So it is same 0 1. This time period is same, 1 0 is also same. So this and this time period is same, and this time period is same. Okay, so 0 1 0 1, it is continuously changing its state. So here what you need actually, if you thinking about once here is your output. 3 number is output pin. So okay, 3 number is your output pin, and here you are getting a square waveform 0 1 0 1 0 1 0 1 for a particular time. So how to define the time? For that I have one very good in a website, Circuit Digest. I am not sponsoring any website. just I am using it because I got a very informative content from this website. So I am just write the values similar I have used in my circuitry. It's a 100 nanofarad capacitor. So I have used 100 nanofarad. What is the R1? This is R1 and this is R2. It is just interchange due to complexity. Okay, and this one is our R2. Okay. So again I have 4.7, 4.7, okay, and 150. R2 is 150. So once you calculate, you can see here you are getting a 47 hertz. It is very nearly to 50 hertz. In India we are using a 50 hertz. That's why we are trying to make inverter to 50 hertz, similar to 50 hertz. And 50-second duty cycle. Duty cycle is again what is the time to remain on and off. So duty cycle should be nearly 50. Duty cycle should be all time in 50. So 50-50 means this is also 50, off time is also 50, on time is also 50. So mostly these two time should be same because we want a output like a AC waveform. So again I am going back to this website and you can see here we are getting 50 hertz, and the time period is also we are getting because in India 50 hertz, so f is equal to 50 hertz and time period t is equal to 1 by f. So 1 by 50 means 20 milliseconds. So 100 plus 100, not a 110 plus 20, it means 20 milliseconds. Okay, so you are getting a very similar output for switching on and off your MOSFETs and for getting a 50 hertz output. So I think so until now you are clear, and you already you know how to design this component, how to design this value, and even you can change the different value according to your requirement. You can use 250, you can use a 120, but why we are using a 150 and why we are, I guess if I use a 140 I am getting exact 50 hertz, but you don't get 140 kilo ohm resistance in the market. You can get only 150 or 120. So according to the availability in the market, you need to design your circuitry. This is most important. You need to understood the behavior of the markets, what is the values available, which components are easily available in market. That component you need to use your in projects. So that's why I have considered 150 here and not a 140. So okay. So yes. So I think so until now you are very clear about this IC-555 and the output of this pin. But the major twist is here. What is a major twist? So here is your output, and what is the output look like 0 1 0 1 0 1 0 1. So do you understood anything by this? Because why important? Because when it is 1, when the output is 1 at this 3 number p, just consider it will operate these two, this one q3 and q4. But when it is 0, when it is 0, when the pin is 0, what will happen? If I don't use, this NOT gate, I am explaining why NOT gate is important. And if I don't use a NOT gate, and similar to Arduino, if I directly connect the two pin similar way, so what happen here? At 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 one at this position, when it is 1, this 2 will operate. This what happened? No, if I remove NOT gate, and if I getting 1 at this point, what will happen? It will operate all the MOSFET at the same time, and it will cause a very clear short circuit. So what is important? These two MOSFETs should not operate at the same time. It should operate a particular time, and if one is in operating state, one another should remain in the off state. So you cannot connect similar to this way. Here I can connect because these two pins, the programming was like one pin is high for a particular time, and after getting this ninth pin off, I will turn on 8 pin on. That's why no any short circuit occur. But here you cannot programming like Arduino. That's why you required NOT gate. So NOT gate, I directly consider NOT gate here and connect. The another advantage of NOT gate, if you notice another advantage of NOT, because what is another advantage? When it is 1, when it is 1, Q3 and Q4 will get off. But when it is 0, when it is 0, 0 means no any voltage here. So no any voltage here means no switching. For switching it, I need to change its state. So 0 to 1, it will change its state from 0 to 1 and trigger these two. So this is how this circuitry, this IC-555 circuitry will use for switching the MOSFETs, and remaining is same from a previous video, same as a previous video, LC filter, and to get a proper sine wave and output. So I think so I should run it for a once for a better understanding. Just I am pressing a run button. Oh, very crystal clear, very crystal clear. Okay, so where is one A number is pin directly connected to here. So okay, so one is high and one is low. So this is this similar waveform. This is a waveform you want to switching on and off this. And you can see here, this is a okay. This happens sometimes because it cannot handle too much load. And okay, just we are trying to input is 17 to 18 volt and output is 110 volt. Okay, and here also you can verify the voltages. It's increase after sometimes and get up until 110 volt. So this is how you can made an inverter with IC-555 circuit. And IC-555 circuit is a very uh, cost efficient circuit. This is a the cost of IC-555 is very less. And here I have directly used a NOT gate. Here you need to not one bit. Here I have directly used a NOT gate. But when you are actually designing the circuit, you need to use NOT gate IC. What is a NOT gate IC? It's a 74. NOT gate IC is a 7404. So you need to use this IC for a NOT gate. Okay. But if you use the IC, then it will cost more. It will cost more. So if you don't want to use a NOT gate, you can use a transistor circuit. Because why? Because we can use a transistor as a NOT gate. We can made a transistor as a NOT gate. So you need to establish a similar circuit that I have already established. Just I am opening it. So you can see here I have replaced NOT gate by similar circuit as mentioned in this Google. And let's check how it's work. It is working similar to our NOT gate or not. So I am just run it, and you can see very clear way or very clearly that we are getting output is very similar to previous one. And also we are getting output near to 110 volt. Okay, it's a 150 170 volt. So you need to just add any variator MOV that to reduce the voltage spike and to protect your load at a secondary side. So I think so thanks for watching this video. And I think so you are very clear about how to design IC-555 as a switching circuit for your inverter. And it's a very cheap circuit and very feasible circuit. Yeah, and when you are using Arduino is a very costly. The price of Arduino in India is 600 to 700, and you need to program also, and it is not feasible sometimes. But if you made a circuit, you can see here every each and every component you can solder on one PCB board, and you can easily made a inverter just by 12 volt to 150 or 160 volt. It is enough to turn on your LED bulb or small equipment that conserve very low power. So I think so everything is very clear as crystal. Thanks for watching this video. If you have any query, just comment I will definitely define. If you want hardware of the this module, you can connect with me through my email ID. And if you want these two models, the two model, one with a not gate and one with a transistor as a not gate, these two model, this file, the Proteus file, you will get in the description box. So again, thanks for watching this video. And